Okay, hello guys. Today I have come up with a new questions which is the example 2.10 of class 11 physics books. Okay, here two resistance are given. R1 is 100 plus 3 ohm and R2 is 200 plus 4 ohm. And first you should know that this 100 is our measured value and this 3 ohm, right? This 3 ohm is our it is our delta r1. Okay, delta r1 is our absolute error. So this 3 ohm is our absolute error of r1 and this 4 ohm it is the absolute error of r2. Okay, and this 200 is the measured value. Well, absolute error is the difference between the measured value and the true value. Okay, and in these questions it is asked to find out the r equivalent of series and the parallel. So for series it is simple. There is nothing much to do, just r equivalent. For series you just have to add up the resistance. Okay, r1 plus r2, so it gives us 300. Well, for error part there is a rule. If it is a additions, okay, if the quantity gets added, then their absolute error also gets added. Okay, and for subtraction also same. And for the case of quotient or for the case of the quotient and the product, that time we have that time their relative error gets added. Okay, so with the help of their relative error we can find out the absolute error, but here the quantity are getting add up. So as we know that the rule is that their absolute error will also gets up, so we simply add this 3 plus 4 ohm, which is their absolute error, so it gives us 7 ohm. So this is the absolute error of the R equivalent. Okay, now let us find out the R equivalent for parallel. Well, for parallel the formula is R. This is the formula of R equivalent. Okay, for parallel you can see here 1 by R equivalent is equal to 1 by R1 plus 1 by R2, and solving this is our final equation. As you can see, R equivalent is R1 R2 divided by R1 plus R2. And solving this, okay, putting the value in here, r1 is 100 and r2 is 200 and r1 plus r2 which is our 300, and this gives us 66.67 ohm. Okay, now for the error part, as you can see here, it is in the upper part it is product, but in the denominator it is getting add off. So it is a very complex equation, right? We cannot simply apply this formula like for addition part. Like in here we will be finding out their absolute error will be getting out add off, and in here their relative error will be getting add off, and there we will find their relative error with the help of this equation. So it does not work like that. Okay, so what we have to do here is that we have to use this differentiation rule, right? Well, this with the help of this differentiation rule we can find out the a small change in input, how much a small change in output will occur. So with the help of these differentiations we will be finding out this absolute error of R equivalent. Okay, first you should know this formula, the differentiation. Okay, the dx of 1 by x function, 1 by x. Why I have taken this 1 by x? Because here, as you can see, this is the function which is in the form of 1 by x, right? So for this type of functions, this gives us minus 1 by x square. Okay, so this is the formula. So first we have applied here differentiation on both of side, then we will be applying this formula, and applying this formula we get this. Okay, here you can see first you can see here this. Okay, how I have taken this. So we have replaced this dx with this delta x, as because our absolute error is represented in delta x. Okay, well, they are both same, this ddx. Okay, this symbol can be used interchangeably. All right, as you can see here in our next line, by applying this formula I have found out their delta R equivalent. Okay, here you have found here I have found out this is our, you can say this is our equations that I have found out after applying the formula. Okay, now what I have to do is that you have to remove this minus symbol, right? So that our equations becomes simple or easier to solve. So I have removed this minus symbol and I have got this. Now our main motive is what? Our main motive is to find this R equivalent, right? This absolute error of R equivalent. So I will send this R equivalent square this is our measured value on this right side, and it will get multiplied on both of these, right? So here you can see it gets multiplied on both of these, and there is nothing to do now. We just put the value of these R equivalent here, as we have found out in before. R equivalent is our 66.67. We put the value of this, and this delta R1, as I have told you that this delta R1, which is this is our delta R1, this is our delta R1, and this is our measured value. Okay, this is our, you can say this is our R1. Well, this is not written like that. This is written as plus minus delta R1. Okay, and this is also same, plus minus R2. Okay, so you can see here, so we just put a value of this delta R1 and R1 square. Okay, and for this also we put this, similarly we put this value also, and solving these equations we get a value which is 1.77, and we can write it as 1.8 or 1.78, whatever as we like, right? So our final value is R equivalent plus minus delta R equivalent is 66.67 plus minus 1.78, or if you want to write the way book has written, which is 1.8, you can write it, right? So there is no problem. Okay, I hope you have understand whatever I have explained. Thank you.